All right, so we're going to be looking at 2.5, absolute value functions and their graphs. Now, in case you did not know, an absolute value function, when it is graphed, it will look like a V. It will always be a V. Okay? Because we know that when we plug in something in the absolute value, we get positive and negative answers. So that's why we have a center and then answers on both sides that make that V. Okay? Now, the thing that we're going to have to do first is figure out how to find our vertex, the center. So, an absolute value function will look like this. F of x equals the absolute value mx plus b, absolute value plus c. Now, it doesn't mean that we're going to have all those values filled in, but we will have most of them. All right? M cannot be 0. All right, so there will always be something attached to the x here. All right, so examples: y equals absolute value of x, y equals absolute value of 2x minus 4, y equals absolute value of x minus 3 plus 3. We're going to learn how to graph every single one of these. Now, when we do graph these, you guys will have to make tables. Remember how we went over making tables, x and y? Okay. So the vertex of a function is a point where the function reaches a maximum or a minimum. Max or min. So if I looked at this again, you see how the vertex is always the lowest point. So do you think that's a max or a min? It's a min. All right. The way that it's a max is when V is facing down. All right. When the V is facing down. Okay. So steps for solving for the vertex. Whatever is in the absolute value symbols, we set equal to 0 and solve for x. So only what's in between the absolute value symbols. That x value is your vertex. All right. To solve for the y value, we then plug our x value back into the original function. All right. And then solve it. If it's ever set up like this, you'll notice that our y value is your c. Right? It's whatever's being added or subtracted outside the absolute value. All right. To graph now, we're going to set up an xy table and then pick a number smaller than your x value for the vertex and a value larger than the x value for your vertex. And then you plug it in and you solve for the y's. It sounds like a lot, but it's not. You'll notice that we can get this done in just a few steps. So, we want to graph this absolute value. All right. First thing you always need to find is the vertex. Okay. In order to do that, I'm going to take whatever's inside my absolute value. What's inside of it? I'm going to take that. There we go. I'm going to set it equal to 0. Now all you have to do is solve for x. 3x equals negative 12, and then x equals negative 4. All right. Now I can solve for my y value. I take this, plug it back in. Y equals absolute value, 3 times negative 4 plus 12. Y equals negative 12 plus 12. And that equals the absolute value of 0, which is just 0. Questions so far? Did I do anything crazy? No. The next thing you have to do is set up your XY table. I'm going to take my vertex, and I'm going to put it in the middle. Right? Negative 4 and 0. Right in the middle. Remember, the only values we choose, we always solve for y. So I want to choose a number smaller and a number larger. What is a number smaller than -4? What is a number smaller than -4? -5. What is a number larger than -4?
-2.
Good, but I'm going to use -3. And I'm going to show you guys why. Do you notice how -4 vertex and I have the same distance, smaller and larger, one away and one away? Yes, same distance. That's 1, 1. You're going to notice something happens if you do that every single time. Okay. All right, so I'm going to plug -5 in, back to the original. Y equals absolute value, 3 times -5 plus 12. -15 plus 12. And then that's going to be a -3. And then that's just 3. Absolute value of -3 is just 3. Any questions on that so far? Do the next one on your own. Plug in -3 by yourself. Plug in -3 by yourself. Go through all the steps. Go through all the steps. Do not forget the absolute value symbols. Do not take the absolute value of anything until it is fully simplified. And what did you guys get as your answer?
3.
3. You notice how the smaller number and the larger number than the vertex are opposed now? This will always happen. If you go the same distance from vertex, have to go the same distance. Now that does not mean that if you plug one in, you get your answer, you just write it here. Because if I plug this in and let's say I got 2 and this one I got 3, I would know I made a mistake somewhere. I would be able to fix that mistake. Yeah.
So even if we got like -4 and then -8 and 0.
Yes.
Okay.
Same thing. An absolute value is a mirror image of itself going in separate, just with the vertex splitting in half. So now let's plot this. -4, 0. 1, 2, 3, 4. -5, 3. 1, 2, 3. And -3, 3. Plot all the points. Plot them on your own so you know how to do it. Should end up looking like this. We draw the lines from our vertex connecting our points. And you're done. Any questions? Not bad? No. If you follow my steps, that is the biggest problem, guys. You have to actually memorize and practice my steps. This is so easy. If you don't, then you're not going to know what to do on a quiz, and you might forget to do or not be able to solve some problems. All right, next one. What I'd like you guys to do for the next one is to solve for the vertex on your own. Do not choose a larger and smaller value unless you're feeling really confident. But I don't want you guys to do a lot of extra work and get something wrong. This one's going to be a little different. I want to make sure you guys can see it. Solve for the vertex on your own. Solve for the vertex completely on your own. Then he's on with the x and the y.
So when I bring it back in, I was at so like I'll write it, like I'll change that.
I just think plugging in fractions are easier to solve when multiplying than a decimal. Did you not get the notes?
No, I do that.
Are you going to know how to do that later on tonight?
Yeah. I can do that one too, like.
John gets that too.
So did you any value?
The vertex you do not choose. The vertex you find. And I don't want you to choose any value. I want you to choose the easiest values. But you can choose any value.
I chose 0.
You choose 0 already? Okay, well, we don't know what the vertex is. So, I mean. All right, Andrew, you said you know how to do this stuff?
I take it back. I'm a pass.
All right, walk me through the beginning.
Okay, so you want to plug in 0 there, so you do 2x minus 5 equals 0.
Good. 2x minus 5 equals 0. Keep going.
Add 5 to both sides, so you get 2x equals 5 over 5.
Guys, I'm listening to somebody. Go.
You would and then you would divide 2 by 5, and then you get x equals 5 over 2.
All right, I'm also going to write it as a decimal just because it's easier to plot. Okay? All right, so we got 5 over 2. What did you do next?
I did y equals absolute value of 2, parentheses 5 over 2, parentheses minus 5, absolute value.
Excellent. And what did you find you got?
I got y absolute value 5 minus 5, absolute value. Or y equals, and then y equals the absolute value of 0, which equals 0.
Okay, so I'm going to plug. So right here, I'm going to do the decimal instead. Okay. Now, the reason why I choose to do the decimal here, guys, is because when you plot a point, what's easier to plot, a fraction or a decimal? A decimal. Now, I want you to take a few seconds to think. A value smaller and larger, but try it in this distance. Now, you can choose that are really close, but littlest is always nice. So our graph is not super congested. Okay? All right, Ryan.
0 and 5.
Okay, so you went 2.5 up and 2.5 down. That's awesome. You can also do something like 4 and 1. So just choose something that's the same distance away. Very good. All right, do not end up with another fraction if you can. Try to make sure you end up with an integer. Now, there are going to be times that we have no choice. They are going to end up being different spaces. All right, you'll find out when we get fractions like 1/3. If this is 0.33, you're going to have to end up getting different values. All right, it won't be the same distance. All right, so you said 0 and 5?
Yeah.
Okay. Obviously, you chose something different. Yours could be different, and that's fine. It's going to look the same in the end. So let's plug it in. Y equals absolute value of 2 times 0 minus 5. Y equals 0 minus 5. Absolute value of negative 5 equals 5. So I can already predict that this is going to be a 5, but I'm going to check. Because if I would have made a mistake here, I just ruined the entire problem. Do you see how that works? If you make a simple mistake in the first one, and then you just assume it's going to be the same, you just ruined the entire problem. Y equals absolute value of 2 times 5 minus 5. Y equals absolute value of 10 minus 5, which equals absolute value of 5, which equals 5. Now I know I got it right. I went through it and I saw I got the same answer twice, so I'm good now. plot the points. 0, 5. 1, 2, 3, 4, 5. 1, 2.5, 0. And 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Questions? Yeah.
I got 2.
For what?
For the y, I got 2.
Yeah, but you plugged in different values. Yeah. See? Now, if I try to check your values out, when you have 1.5 and you got 2, that's about what I have. So that looks like that's probably right.
Yeah.
And 3.5, yeah, it's going right around 2 right there. So you see how they still look the same? Yeah. Yeah. All right, any questions? All right, the next one's going to be a little different. So when we look at the next one, what I want you guys to do before we even get started is try to figure out what's different about it. Give everyone time to think first, and I'll ask you to answer it.
Well, I don't know how to answer it. Let's see what's different.
That's what I mean.
All right.
Everyone has this copy down? All right. What is different about C than A and B? Come on, Ryan.
It has something outside of the absolute value.
Okay, what's outside? Be specific.
-2 or -2.
The -2. Okay, so -2 is happening outside the absolute value. Excellent. What else is outside the absolute value?
A negative sign.
A negative sign. Now, the negative sign is directly attached to the absolute value. That's going to do something very specific. And that -2 is very significant. All right? You'll see how those two things affect it. All right, let's solve for a vertex. If I'm solving for my vertex here, what's the only thing I really need to be looking at right now?
Absolute value.
The what?
Absolute value.
And what am I exactly going to be setting equal to 0?
That's this one.
Excellent. Only what's inside the absolute value matters for the vertex. All right. Got my XY table going on over here. And -1. Now let's see what happens when I plug in -1. We're going to get a different answer than we did on the last two. What do we get every time for the vertex on the last two? The last two, what's our value next to the vertex every time so far? 0. What do we notice about this? The other ones had 0, this one has a -2 now. Why? What's different? Why do the other ones have 0s? This one's a -2 for the y. Yes, Al.
Because it's something outside of it.
Because of this. The other ones are +0 on the outside. This is -2. This is always going to be your y value. Whatever's being added, subtracted to it, will always be your y value. Always. Okay? So if nothing's being added or subtracted to your absolute value outside of it, it's always going to be 0. If it's +10, it's going to be 10. If it's -4, it's going to be 4. -4. All right? Now I need a value smaller and larger. Smaller and larger. All right?
-2.
And?
Oh, -2 and put 0.
Yeah, 0 is perfect. Same distance. So I know that I should get the same answer for both. Okay? Now I plug them in. Y equals -2 plus 1 minus 2. -1. So I have the negative absolute value of -1, absolute value minus 2. -1 minus 2, and that's a -3. Again, instead of just assuming that -3 is right, I'm going to do the work again. This time with 0. 0 plus 1 minus 2. 1 minus 2. -1 minus 2. -3. It's an easy way to check your work, guys. It doesn't take that long. It's more important that you get it right than you get it done quick. All right. It's also important that you practice solving these. I can't tell you how many times people try to do this on a quiz or test, but because they didn't practice it enough, they mess up with the absolute values. I plot all 3 points. -2, 1, 2, 3. -1, -2. 0, -3. What do you notice about this one?
It goes down.
Why do you think this one goes down, Ryan?
Is there stuff on the outside of absolute value?
Close. Something very specific. Yes, Ryan.
The negative.
It's the negative attached to the absolute value. Not this negative.
The negative.
Not this negative. That one. This negative right here, that's the reason why it's facing down. So if this absolute value is positive, it will always face up. If it's a negative there, it will face down. And then this would be my max. That's what a max looks like. Your vertex is the highest point of your graph. Yes, Ryan? Yes. Any questions? Any questions about this at all? Do not erase it. Got it. What I'd like you guys to do, for anybody who's done, please get started on the very next one, D. Please get started on D. Yes.
For when you get -1 minus 2, why do you do that for value?
Am I up here?
Yeah.
So the absolute value of -1 is
1.
and then that negative still stays.
Oh, yeah, I got you.
Okay? Be careful about that. It's a really, really big mistake people make. Again, guys, you want to plug in both. Okay? Do not, I showed you the trick for a reason, so you know that these should be the same answer, not so you can shortcut yourself, but so you can always get it right. Practice solving these. It's extremely important. Guys, this video will be online tonight for when you're solving these. And you will want graph paper, so make sure you grab graph paper before you leave the room if you don't have any yet. You done there? Go as far as you can, guys, with the next problem. Let's see if you get everything right. Good? Everyone else good copying this down so I can move on? All right. Since you guys have the head start, I am going to go about solving the next one all the way up until the vertex, and then I'll stop there and see what value you guys chose. Okay. Do we have 3, 5 for our vertex?
Yeah.
Okay. What values do we choose for smaller and larger? Yes, Brooke.
I picked 2 and 4.
2 and 4?
Yeah.
Excellent. Okay. Did everyone else choose 2 and 4 or something else? Something else? It's okay. You chose what? That's fine. As long as you're going the same distance, that's perfectly fine, guys. Our graphs will look the same still. So you guys solve it with 1 and 5, I'll solve it with 2 and 4. Y equals absolute value of 2 minus 3 plus 5. Absolute value negative 1 plus 5. 1 plus 5, and that's 6. So I'm looking for 6 for my 4 one. Y equals absolute value of 4 minus 3 plus 5. Y equals 1 plus 5. 1 plus 5, and that's 6. Plug my values in. 1, 2, 1, 2, 3, 4, 5, 6. 3, 1, 2, 3, 4, 5. 4 and 6. And your graphs will look something exactly like that. Okay? Any questions, guys? Okay. Guys, you may pack up. Your homework will be page 90, 1 through 9 all.